Coefficient of x squared in the expansion of 4 plus ax times 1 plus x over 2 to the power of 6 is 3. We're required to find the value of the constant a. Yeah, so all we're interested in is the coefficient of x squared. So we are not going to expand this binomial completely, since all we require, once we've multiplied the required terms by this binomial 4 plus ax, all we require are terms in x squared. So we're not going to expand 1 plus x over 2 to the power of 6 completely. Yeah, so we have the expansion of this binomial. We are only interested in, however, in the terms that will give us a term in x squared once we've actually multiplied it by this binomial 4 plus ax. The first term in the expansion doesn't contain a term in x, so we can disregard that. The second term has a term in x, and when we multiply that by the x in this first binomial, we are going to get an x squared. So we are interested in this term here. The third term does contain an x squared, and when we multiply by this binomial, we'll be multiplying by the 4. We're going to get a term in x squared, so we are interested in this term as well. The fourth term of the expansion contains an x cubed, so that won't give us a term in x squared, neither will the following three terms. So the only terms we are interested in will be 6 choose 1 and the 6 choose 2 coefficient terms. So we're now just going to evaluate those. So 6 choose 1 will be 6. 6 times x over 2. That will give us 3x. 6 choose 2 will be 15 times a quarter, so it will be 15 over 4x squared. Now these terms here, when we multiply by 4 plus ax, the first two terms will give us a term in x, so we're not interested in that. The next two terms, 3x and ax, will give us a term in x squared, which will yield 3ax squared. The inners will give us a term in x squared. It will be 15 over 4 times 4, which is going to be 15x squared. And then the last two terms will give us a term in x cubed. I'm not interested in that. So this is what we are going to be using now. And the coefficient of this expression here, the coefficient of x squared in this expression, has to equal 3. So the coefficient of x squared is 3a plus 15, and that must equal 3. So 3a equals minus 12, and a therefore equals minus 4. Question 2. The point M is the midpoint of the line joining the points 3, 7 and minus 1, 1. We're required to find the equation of the line through M, which is parallel to this line, x over 3 plus y over 2 equals 1. Okay, so M is the midpoint of these points, which we'll just call A and B. So the midpoint of AB will be x1 plus x2 over 2, so 3 minus 1 over 2, and the y coordinate will be y2 plus y1 over 2, so 7 plus 1 over 2. 2 over 2 is 1, and 8 over 2 is 4, so M is the point 1, 4. Now, we are required to find the equation of the line that passes through M and is parallel to this particular line over here. So we need to write this equation, express this equation in standard form so that we can get the gradient. It's important because the line that we're looking for is parallel to this particular line, so it's got the same gradient. So we're going to multiply everything through, every term here, through by 6, which is the LCM of 3 and 2. So we'll have 2x plus 3y equals 6. 3y equals minus 2x plus 6. In standard form, y equals minus 2/3 x plus 2. So the gradient of this line is minus 2/3. So therefore the gradient of the line we're looking for that passes through M and is parallel to this second line is also going to be minus 2/3. So y minus y1 equals m times x minus x1. You can also use y equals mx plus c. You'll get the same equation. It's just a lot quicker to use the first equation over here. So y minus 4 equals minus 2/3 times x minus 1. Y equals minus 2/3 x plus 2/3 plus 4. So y equals minus 2/3 x plus 14 over 3, which you can also express as 3y equals minus 2x plus 14. There just might be a neater way to express the equation of the line. Question 3. A curve is such that dy dx equals k over root x, where k is a constant. The points P, 1 minus 1 and Q 4, 4 lie on the curve, and we're required to find the equation of the curve. Okay, so what we've been given here, dy dx, is the derivative function of a curve of another function. So because we've got the derivative function, we're required to find the function itself from which the derivative came from. We'll be integrating this expression for dy dx. So y equals, k is a constant, so we can actually pull that out of the integration. K times the integral of 1 over root x, and then we integrate with respect to x. So it's k times the integral. 1 over root x is 1 over x to the half, which is x to the minus a half. So y equals k times the integral of x to the minus a half. We're going to add 1 to minus a half, we get a half, and then divide by a half, and we add the constant of integration plus c. So y will equal k divided by a half is going to be 2k x to the half plus c. So this is the equation of the curve. Now we need to determine, in order to get the equation of the curve, we need to know the value of k and the value of c. So we need two pieces of information since we've got two unknown variables here. So that information comes from the points that lie on the curve in the form of p and q. So in turn, we're going to substitute these 2 points into this curve. So minus 1 equals 2k times 1 to the half plus c. Minus 1 equals 2k plus c. C is minus 1 minus 2k. So there's one equation. Now we substitute the point q into the equation of the curve. So 4 equals 2k times 4 to the half plus c. 4 equals 2k. The square root of 4 is 2. So 4 equals 4k plus c. C equals 4 minus 4k. And there's the second equation relating c to k. So now we can just equate these two expressions to each other. So 2k equals 5, k equals 5 over 2. And c will be minus 1 minus 2 times 5 over 2. So that's minus 1 minus 5 is minus 6. Therefore, the equation of the curve is given by y equals 2 times 5 over 2 x to the half minus 6, which equals 5x to the half minus 6. And we're going to express this curve as the equation rather as 5 y equals 5 root x minus 6. The reason we're expressing it as a surd is because the original form was as a surd. So you'll leave the equation of the curve as y equals 5 root x minus 6. The diagram shows a circle with center O and radius r centimeters. Points A and B lie on the circle, and angle AOB is 2 theta radians. The tangents to the circle at A and B meet at T. We're required to express the perimeter of the shaded region in terms of r and theta. Okay, before we get to that, let's just mark on the diagram everything that we know from what's been given to us. O is the center of the circle, so and OA is r centimeters. OB is also radius, that's also going to be r centimeters. OA being a radius and AT being a tangent means that angle OAT is 90 degrees, radius perpendicular to tangent, and that's the same case for angle OBT also being 90 degrees since BT is also a tangent. We're required to express the perimeter of the shaded region in terms of r and theta. So the perimeter of the shaded region will be this arc AB, which you're going to get from the sector OAB, the length of tangent AT plus the length of tangent BT. So the sum of these, the arc and the lengths of the tangents, will give us the perimeter of the shaded region. So for the arc length, we'll start with the arc AB. The arc length will be r times the arc angle, which in this case is 2 theta. So r times 2 theta. That's going to be the arc length, AB. We now need to find the length of tangent AT and BT. Now we're going to construct join O to T. The reason we do that is because it forms a right angle triangle, triangle OAT and OBT. And from that right angle triangle, we can use Pythagoras' theorem or a trig ratio to find the length of AT and BT, which are going to be identical. We know that from Euclidean geometry that two tangents drawn from the same point outside of a circle will equal in length. So we know that AT equals BT. So once we've got one of these two, we can just double it to get the sum of those lengths. And then we can add it to the arc length AB and get the perimeter of the shaded region. Okay, so AT divided by, now before we get that, we've got angle O1 and O2. We've created two right angle triangles here by joining O to T. Now because these triangles, triangle OAT and OBT, are identical, they're congruent, that means that angle O1 equals angle O2. And since angle AOB is 2 theta, that means that O1 is theta and O2 is also theta. So inside one of these right angle triangles, doesn't matter which one you start off with, relative to the angle theta, AT is the opposite side and OA, the radius, is the adjacent side. So opposite over adjacent is tan. So AT over R is going to be opposite over adjacent. It's going to give us tan theta. So AT equals R tan theta, and this is also the length of BT since they are AT equals BT. So the perimeter of the shaded region will be the arc length AB, which is 2R theta, plus AT plus BT, which are both equal to R tan theta. So we'll have 2R tan theta. And we can clean this up a little bit by taking out a common 2R, just looks a little bit neater. 2R times theta plus tan theta, and this is the perimeter of the shaded region. Next, we're required to find the area of the shaded region, given r equals 5 and theta equals 1.2. So the area of the shaded region, if we consider the area of a right angle triangle, and we're going to find the area of both right angle triangles OAT and OBT. So that'll basically give us the area of the quadrilateral AOBT, and then we subtract the area of sector OAB, and that will give us the area of the region that we are looking for. So the area of the shaded region will be the area of AOBT, which is the area of the quadrilateral, minus the area of the sector AOB. Now, the area of the quadrilateral comprises two right angle triangles. So once you've got the area of one right angle triangle, we're just going to double that. So we'll have 2 times the area of one right angle triangle is going to be a half base times height. The base will be R and the height AT, or vice versa. It doesn't make a difference which one is which. So it'll be r times AT is r tan theta, and then we double this. This is the area of one right angle triangle. We double that because we've got two right angle triangles, which basically comprises the quadrilateral AOBT, and then we subtract the area of the sector, which is a half r squared theta. In this case, that is the arc angle is 2 theta, so it's half r squared, and the arc angle is 2 theta. So that will give us 2 times a half, and then r squared tan theta minus r squared theta, and that will equal r squared times tan theta minus theta, and that's the area of the shaded region. Now we're given that r equals 5, so the area will be 5 squared, which is 25 times theta is 1.2, so tan 1.2 minus 1.2, and all of that times 25. So the area of the shaded region is 34.3 centimeters squared. Question 5. The diagram shows a solid cone which has a slant height of 15 centimeters and a vertical height of 8 centimeters. We're required to show the volume V of the cone is given by V equals pi by 3 times 225h minus h cubed. Okay, well, firstly, the volume of a cone is a third the area of the base times the perpendicular height. Now, the base of a cone is a circle, so the volume will be a third pi r squared times the perpendicular height h. So a third pi r squared h is the volume of a cone. So we need to find the radius of this cone. So we're going to drop the perpendicular to the center of that base, forming the radius of the circle, and we've got the perpendicular height h. So using Pythagoras' theorem, obviously these two, the vertical line and the horizontal line, the radius are perpendicular to each other. We dropped it perpendicular. So using Pythagoras' theorem, 15 squared equals h squared plus r squared. So r squared equals 225 minus h squared. And we're not going to square root that because we have got an expression. We have got r squared as part of our volume. So we'll just leave it as it is. Volume will be a third pi times r squared, which is 225 minus h squared times the height h, and then just putting it into the form that they require it in. We're going to bring the h into the bracket, so the volume will be a third pi times 225h minus h cubed. Given that h can vary, find the value of h for which v has a stationary value, and determine the nature of the stationary value, showing all calculations. Okay, so we're required to find the value of h for which v has a stationary value. Now, stationary values relate to stationary points, turning points, however you want to look at it. And that happens when the derivative of a function equals 0. So we are going to find the derivative function dv dh and equate that to 0 to find the stationary value. So dv dh. Before we do that, we're first going to bring the third pi into the brackets. We can use the chain rule, but if you haven't used the chain rule before, then this is the way that you need to approach the derivative. So we'll have 225 over 3 pi h minus a third pi h cubed. And now we can find the derivative function dv dt. So the derivative, sorry, not dv dt, dv dh. 225 pi over 3 is a constant, and the derivative of h is 1, so we'll just have 225 pi by 3 minus A third pi is a constant. A third pi times 3 will just give us pi, and then h squared. Now for the stationary points, the derivative function dv dh will equal 0. So 225 pi by 3 minus pi h squared equals 0. Can cancel the pi there, so h squared is 225 over 3. H will be 15 divided by root 3, which equals, when you rationalize the surd, 5 root 3. To rationalize the surd, we're just going to multiply by root 3 over root 3 and multiply the numerators and the denominators together. So 15 root 3 over root 3 times root 3 is 3. 15 divided by 3 is 5. So we get 5 root 3. And this is just how surd should be expressed. You should never express a surd in a denominator. Okay, so h equals 5 root 3 centimeters. That will give us the stationary value. The nature of the stationary value, we are going to find the second derivative form. So the second derivative will be 225 pi over 3 is a constant, so the derivative of that will be just be 0. The derivative of minus pi h squared with respect to h is going to be minus 2 pi h. And we want to know what the nature of the stationary value is. H is 5 root 3, so the second derivative when h equals 5 root 3 will be minus 2 pi times 5 root 3. We don't care what the value is, it would be negative. And that implies that we have a maximum stationary point because the second derivative is less than 0. Given that x is greater than 0, find the two smallest values of x in radians, for which 3 tan 2x plus 1 equals 1. Show all necessary working. Okay, so 3 tan 2x plus 1 equals 1. Now, since we're solving for x, we need to isolate the trigonometric ratio. So we'll divide both sides by 3 first. So tan 2x plus 1 equals a third. And now we're going to find the reference angle. So the reference angle will be 2x plus 1 equals. Now we're working in radians, so make sure that your calculator is set in radians. Shift tan a third is 0.32175. Now for a positive ratio, the angle 2x plus 1 will lie in the quadrant where tan is positive, which is the first quadrant and the third quadrant. So the first quadrant, this will be the acute angle. So 2x plus 1 equals 0.32175. 2x equals minus 0.67825. We're not going to solve for x here because this is negative, so we'll just invalidate that immediately because we were told that x is positive. And the third quadrant, 2x plus 1 equals 180 plus. Third quadrant is 180 plus, 180 degrees plus, which is pi plus. So pi plus 0.32175. 2x equals 2.4633, which is positive. So x will be 1.23167 radians. Function f of x equals 3 cos squared x minus 2 sin squared x is defined for x between 0 and pi. Express f of x in the form a cos squared x plus b, where a and b are constants. Okay, so since we need only the trig ratio cos, we will be expressing sin squared x as 1 minus cos squared x, which we get from the square identity. So f of x will be 3 cos squared x minus 2 plus 2 cos squared x. F of x therefore equals 5 cos squared x minus 2. So a equals 5 and b equals minus 2. To find the range of f of x, we can do so either algebraically or graphically. So starting with algebraically first, the smallest value of x is 0. So cos squared 0 will have a value of 1. That means that f of 0 will be 5 times 1 minus 2, which equals 3. When x equals pi, then cos squared pi will equal cos pi is negative 1. Negative 1 squared is positive 1. So for both x equals 0 and x equals pi, the function f of x has a value of 3. Now, this is the maximum value for f of x. To find the minimum value of f of x will occur when this term 5 cos squared x equals 0, in which case the minimum value of f of x will be minus 2. This minimum value of f of x occurs when x equals pi by 2 or 3 pi by 2, since cos pi by 2 equals 0, which means cos squared pi by 2 will be 0, and therefore you get the minimum value of minus 2 when x is pi by 2 or 3 pi by 2. So the range is y is an element of minus 2 to 3, or you can express this as an inequality f of x is less than or equal to 3, greater than or equal to minus 2. Now graphically, we draw the sketch graph of y equals 5 cos squared x minus 2. The minimum value we can see from the function occurs at x equals pi by 2 and 3 pi by 2. We get a minimum value of negative 2, and the maximum value occurs where x equals 0, pi, and a 2 pi, and that value is 3. So the maximum value of that function is 3. So again, y, the range is y as an element of minus 2 to 3, or you can express it as an inequality. Question 8. Over a 21-day period, an athlete prepares for a marathon by increasing the distance she runs each day by 1.2 kilometers. On the first day, she runs 13 kilometers. Find the distance she runs on the last day of the 21-day period. Okay, so on day 1, she runs 13 kilometers. So our first term will be 3, or rather 13. She increases the distance she runs each day by 1.2 kilometers. So we have a common difference of 1.2. Find the distance she runs on the last day of the 21-day period. So we're required to find how fast she runs on day 21. So that's term 21, which is a plus 20d. So that's 13 plus 20 times 1.2, which is 37 kilometers. Find the total distance she runs in the 21-day period. Because we want total distance, we're looking for the sum to n, in other words, the sum to 21 terms. Given a is 13, d is 1.2, and n is obviously 21. So the sum to n terms of an arithmetic sequence is n over 2 times 2a plus d times n minus 1. The sum to 21 terms is 21 over 2 times 2 times 13 is 26, plus 1.2 times 20. So the total distance that she runs over the 21 days is 525 kilometers. First, second, and third terms of a geometric progression are x, x minus 3, and x minus 5 respectively. Find the value of x. Okay, so we've got the first three terms of the GS, which means it would have a common ratio between successive terms. So x minus 3 over x equals x minus 5 over x minus 3. X minus 3 all squared equals x times x minus 5. So x equals 9. The sequence is therefore 9. 9 minus 3 is 6. And then 9 minus 5, 4. Common ratio is 6 over 9, which is 2/3, which equals 4 over 6. A is 9 and R is 2/3. We're required to find the fourth term of the expression. So the fourth term of a G S is given as AR cubed. So it'll be 9 times 2/3 cubed. 9 times 8 over 27, which is 8 over 3. Finally, find the sum to infinity of the progression. So the sum to infinity is given as A over 1 minus R, which is 9 over 1 minus 2/3, 9 over a third. The sum to infinity is therefore 9 times 3, which is 27. Question 9. Functions f and g are defined x equals 2x squared plus 8x plus 1. G of x equals 2x minus k, and for x is an element of real numbers, where k is a constant. Find the value of k, for which the line y equals g of x is a tangent to the curve y equals f of x. Now, for g of x to be a tangent to f of x, there can only be one point of intersection for the two functions. So when we equate f of x to g of x, we will establish an expression from which we can determine the discriminant, and from that the discriminant will have to be equal to 0, because that's what gives us equal roots. So 2x squared plus 8x plus 1 equals 2x minus k. 2x squared plus 6x plus 1 plus k equals 0. The discriminant delta is b squared minus 4ac. So that's going to be 6 squared minus 4 times 2 times 1 plus k. 36 minus 8 minus 8k. So delta will be 28 minus 8k. Now, for equal roots, delta equals 0. So 28 minus 8k equals 0. 8k equals 28. K equals 7 over 2. So if k is 7 over 2, or 3.5, then the line g of x equals 2x minus 7 over 2 will be a tangent to the function f of x. And we can actually illustrate this graphically as well. So when k is 7 over 2, then we've got the resultant quadratic 1 plus 2x squared plus 6x plus 1 plus 7 over 2 equals 0. So the quadratic is 2x squared plus 6x plus 9 over 2 equals 0. Multiplying through by 2 just to get a quadratic we can factorize. Will give us 4x squared plus 12x plus 9, and factorizing that will give us 2x plus 3 times 2x plus 3 equals 0. So x is minus 3 over 2. And it shouldn't be surprising we only have one x value here, because this is the x coordinate of the point of intersection between the straight line, the tangent, and the curve f of x. So the y value, so g of minus 3 over 2 equals 2 times minus 3 over 2 minus 7 over 2. So it's going to be minus 3 minus 7 over 2, which will be minus 13 over 2. So the point of contact between the tangent and the curve is the point minus 3 over 2 minus 13 over 2. We're doing all of this just to illustrate the solution graphically. So sketching the function f of x and g of x is 2x minus 7 over 2. The point of contact is minus 3 over 2 minus 13 over 2, which is indicated over there. So this just illustrates the fact that g of x is a tangent to f of x at the point minus 3 over 2 minus 13 over 2, and that occurs when the value of k is 7 over 2. Next, in the case where k equals minus 9, find the set of values for which f of x is less than g of x. So again, we can do this both algebraically or graphically, and we'll do it algebraically first. So 2x squared plus 8x plus 1 is less than 2x minus 9, so it's going to be 2x plus 9. We can then get a simplified quadratic expression, 2x squared plus 6x minus 8 is less than 0. We can divide through by 2. X squared plus 3x minus 4 is less than 0. So this will factorize as x minus 1 times x plus 4. The critical values will be x equals 1 and x equals minus 4. So the solution lies in the region, the negative region here. So x is greater than minus 4 but less than 1. So that's the solution algebraically. Graphically, we are going to sketch the function x squared plus 3x minus 4. So the critical values are the x-intercepts. So we'll have x equals 1, x equals minus 4. Line of symmetry, we don't care too much about any other detail. We just need to sketch the x-intercepts and the general shape of the curve. X squared, the coefficient of x squared is positive, which means that the quadratic shape's up. So our function will look something like that. And what we're interested in are the values of x where y is less than 0, where y is negative. And that happens between minus 4 and 1, because this area of the function, this section of the function, lies underneath the x-axis where the y values are negative. So the solution is minus 4 is, well, the x is greater than minus 4 and less than 1. So we get the same solution graphically that we did algebraically. In the case where k equals minus 1, find g to the minus 1 of f of x and solve the equation g to the minus 1 of f of x equal to 0. So k is negative 1, which means that g of x will be 2x minus minus 1 or 2x plus 1. We're required to find e to the minus 1 of f of x, which means we're looking for g to the minus 1 of 2x squared plus 8x plus 1. So before we can determine this expression, we need to find the inverse function g to the minus 1 of x. So given that g of x equals 2x plus 1, the inverse function will be given as x equals 2y plus 1. So 2y equals x minus 1, y equals x minus 1 over 2. So this is now your inverse function of g. So g to the minus 1 of 2x squared plus 8x plus 1 will give us, substituting 2x squared plus 8x plus 1 in for x in g to the minus 1, will give us 2x squared plus 8x plus 1 minus 1 divided by 2, which is 2x squared plus 8x divided by 2, which is x squared plus 4x. And we need to solve this equation by solve for x rather by equating it to 0. So x times x plus 4 equals 0, x equals 0, or x equals minus 4. Next, express f of x in the form 2 times x plus a all squared plus b, where a and b are constants, and hence state the least value of f of x. Okay, so we basically need to express f of x, which is in standard form, in turning point form. So to do that, we're going to be completing the square. And the first thing we do is ensure that the coefficient of x squared is 1. So we're going to divide every term by 2. So we have 2 times x squared plus 4x plus a half. And now we add a bracket squared. and subtract the same bracket squared. The content of that bracket is half the coefficient of x, so half of 4 is 2. So we have 2 times the first 3 terms inside the bracket. Brackets form a perfect square trinomial, so which is x plus 2 all squared, plus a half minus 4. So that will equal 2 times x plus 2 all squared minus 7 over 2, and bringing the 2 back into the square brackets, 2 times x plus 2 all squared, 2 times minus 7 over 2 is minus 7. So it is now in this form, 2 times x plus a all squared plus b, so we can infer that a equals 2 and b equals minus 7. From this expression for f of x, we can deduce that the turning point of the function is minus 2 minus 7. We know that the function shapes up because the coefficient of x squared is positive, it's 2. So the function is going to shape up. The turning point is minus 2 minus 7. And from that we can deduce then that the smallest y value is minus 7. The range of this function is y is the element of minus 7 to infinity. The arms point up, so the y values get larger. We can also express this as an inequality. The range, that is, f of x is less than, rather is greater than or equal to minus 7. So the smallest possible value for f of x is going to be minus 7. The diagram shows part of the curve y equals 1 minus 4 over 2x plus 1 all squared. The curve intersects the x-axis at A. The normal to the curve at A intersects the y-axis at B. Obtain expressions for dy dx and the integral of y dx. Okay, so y equals 1 minus 4 over 2x plus 1 all squared. Okay, so y equals 1 minus 4 times 2x plus 1 to the minus 2. We need to get this into differentiable ready form before we can find an expression for dy dx. So dy dx will be the derivative of 1 is 0. Minus 4 times minus 2 is 8 times 2x plus 1 to the minus 3 times the derivative of 2x plus 1, so we're going to times by 2. So that equals 16 divided by 2x plus 1 to the power of 3. And then to find the integral of y dx, that would be the integral of 1 with respect to x will just be x. Minus 4 is a constant. We then integrate 2x plus 1 to the minus 2, so we add 1. So we'll have 2x plus 1 to the minus 1 divided by a minus 1. And we also have to divide by the derivative of 2x plus 1, so we divide by 2 plus c. So that'll equal x plus 4 divided by 2 is 2 times 2x plus 1 to the minus 1 plus c. Just clean that up a little bit. X plus 2 over 2x plus 1 plus c. Okay, next to find the coordinates of b, which is the y-intercept of the line AB, we're going to have to first find the equation of AB. Now AB is a normal to the curve. Now to get the equation of a normal, we are first going to need to find the gradient of that normal, and we get that from the gradient of the tangent. So if we have a tangent at A, okay, we determine the gradient of that tangent from the derivative function of the curve y. So the derivative function dy dx is 16 over 2x plus 1 cubed. Now we need to know what the value of this gradient is. This represents the gradient of a tangent to the curve. We need to know the value of that gradient, and we need to know the x, the point of contact A, to determine the value of that gradient. Now the curve intersects the x-axis at A, right? So the curve cuts the x-axis at A. That means that A's y value is going to be 0. So we're going to take the curve y equals 1 minus 4 over 2x plus 1 all squared. Y is going to be 0, right? Because A is an x-intercept. We're looking for the coordinates of A now. So y equals 0, and we're just going to solve now for x. So 0 equals 2x plus 1 all squared minus 4. 2x plus 1 all squared equals 4. That means that 2x plus 1 equals plus or minus 2. We square it in both sides. 2x is plus or minus 2 minus 1. So 2x equals 1, or 2x equals minus 3. X equals a half, or x equals minus 3 over 2. Minus 3 over 2 is not applicable because A lies on the positive x-axis, so A is the point, a half, 0. We can now determine the value of the gradient of the tangent at A, since we have the point of contact A. So dy dx evaluated at x equals a half will be 16 over 2 times a half plus 1, and that is all cubed. 16 over 2 times a half is 1, 1 plus 1 is 2, 2 cubed is 8, 16 over 8, which equals 2. This now represents the gradient of the tangent to the curve at the point A. The gradient of the normal at A is therefore going to be minus a half, because the gradient of a normal times the gradient of a tangent is negative 1. The two lines are perpendicular to each other. The point of contact is A, which is a half, 0. So we can determine the equation of the normal. You can use y equals mx plus c as well, if you prefer. Doesn't make a difference. Y minus 0 equals minus a half times x minus a half. Y equals minus half x plus a quarter. And this is the equation of the normal to the curve at A. Now to find the coordinates of B, B is the y-intercept of this line. So we're going to put x equal to 0. So y-intercept x equals 0. So y equals 0 plus a quarter. So B is the point, 0, a quarter. Finally, to find the area of the shaded region, we are going to, because the curve, the line AB, part of it lies above the x-axis and part of it lies beneath the x-axis. We can't just subtract the one curve from the other, right? So we're going to break this shaded region into two separate regions. We'll have triangle OAB, which lies above the x-axis, and then we've got the area of the shaded region beneath the x-axis, bound by the curve, the y-axis and the x-axis. So we're going to determine the area of each of these and then add them to get the area of the shaded, the total area of the shaded region. So the area of triangle OAB will be a half base times height. So it will be a half OB times OA. B's coordinates are 0, a quarter. A's coordinates are a half, 0. So the length OB will be a quarter units. And OA likewise will be half a unit. So that will be 1 over 16 units squared. That will be the area of triangle OAB. The area of the shaded region bounded by the curve below the x-axis will be the integral from x equals 0, because this is the boundary integration, or x equals 0 to x equals a half, which is the point A, a half, 0. And the curve that we're dealing with is 1 minus 4 over 2x plus 1 all squared, and we can integrate that with respect to x. So that equals the integral from x equals 0 to x equals a half. Just putting this into a form that we can integrate. So we can now integrate this. So we will have x minus 4 times 2x plus 1 minus 2 plus 1 give us negative 1, and we divide by negative 1. And we also multiply by 1 over the derivative of 2x plus 1, so multiply by a half, and this is evaluated between x equals 0 and x equals a half. So we'll have x plus 4 over, rather, we have x plus 4 divided by 2 is 2, 2 times 2x plus 1 to the minus 1 between x equals 0 and x equals a half. Just going to write this in a neater form, makes it easier to work with. So that would be a half plus 2 times divided by 2 times a half plus 1 minus, where x equals 0, we'll have 0 plus 2 over 2 times 0 plus 1, and that will equal a half plus, it's going to be 1 minus 2, and that'll be a half minus 1, which is minus a half. Okay, what the minus half means is simply that the curve lies underneath the x-axis, right? So the area will be a half a unit squared. So the total area will be, the area of the triangle was 1 over 16 plus a half. So 1 over 16 plus 8 over 16, which equals 9 over 16. And this is the area of the shaded region, 9 over 16 units squared.